Ja ne pričam toliko dobro srpski kao moja supruga, ali probat ćemo malo o početku. Ja nisam toliko uspešno kao Mina, ali moram da kažem da ja sam bio seventh in the Swedish Championships of friction fire, of making fire with sticks. It has very little to do with this presentation, but it might be important to know a little bit of my background. Otherwise, I am a software engineer. I have been working in the software industry since 1998, starting in IBM, then working where we met with my wife and I in a startup company doing various administrative software. But then I thought software was so much fun that I cannot only do it as work, but I have to do research on software development. So I quit my job at the startup company and I went to university to become a teacher in software development and development of administrative IT systems. And this was so much fun that I wanted to do research, so I then ended up doing research in cybersecurity and development of secure software systems, which I did a little bit research in, and I'm still lecturing a little bit on that. But then when I had been doing this, I have a weakness, and that is that when I think I'm reasonably good at something, I want to try something else, because then I get a little bit bored. And then, since I'm not only doing software development, but I'm also taking care of the family imanje. So we have forest, we have 50 cows and trees and whatever. I started to become interested in geographical information systems and doing maps. And it was in fact in the forest that I came to be recruited to Navigraf. So I was in fact out hunting, and I had forgotten about my job interview with Navigraf. But I thought, okay, I didn't really need a job. I had a good job, but yeah, well, okay. I'd forgotten the time, so let's take the interview in the forest. So we had the interview on a video in the forest while I was waiting for a moose to come. There came no moose, but I got a job. And what I was explaining then was that I did, in fact, try out mapping because of my son Maxim. He started with flight simulation, and I very much liked flight simulation when I was young, so I thought it would be nice to do a map of the property so that we can fly over the forest and see how it looks from flight simulation. Because the standard scenery in X-plane, as we had at the point in time, was not very accurate. And since we are doing lots of mapping of the forestry, of the forest, I had access to extremely accurate mapping data over the forest. In fact, I can, without lying, tell you that I know the position and the height of every single tree in our forest. So I thought it would be nice to use this and see how accurate of a map we can produce, and if we can produce a three-dimensional map of the forest and fly over it. And so, yeah, we did that. And then at that point in time, Navigraf called me and said, oh, we're doing mapping for flight simulation. And I said, oh, how interesting, I just did that. And then turned out, yeah, you can get paid for doing what you thought was fun. So I thought, well, I might consider it. But then, yeah, I forgot about the interview, but then anyway, I ended up at Navigraf, which is a very interesting company, doing mapping for flight simulation. So we are doing mapping for flight simulation. That's what we're doing, and we're doing flight planning for flight simulation. And why do we do this? How can anybody be interested in this? Well, it turns out that we have about, I think, soon 100,000 customers over the world who are using our software. And when we went to the Flight Simulator Expo in Houston, Texas this year, we asked the audience, about 500 people, how many people are using our software? And it turned out like almost the entire audience that was on Flight Simulator Expo was using our software. And you might ask yourself why, and I think the reason is that flight simulation people who are really interested, they want the simulation of flight to be as real as possible. And what we are providing is a flight planning solution which uses the exact same data that the airline pilots have. But not only that, in fact, we are providing it in a better package, with a better interface and an easier to use way, in fact. Because we are not burdened by the regulations of the air industry. Our software actually cannot, by the license, be used for real flight planning. Because then we would have to certify our software in various ways. So this means that we can actually make flight planning in a better way than what the professional flight planning software companies can do. So we can be more innovative about new features, we can be faster in developing the user interface and so forth, and generally be much more flexible when it comes to what we do with the software. So our mission is to provide this professional data to the flight simulation community. And this has become quite a successful business. By the way, how many of you here are doing flight simulation? One? Only one? Two? Three, maybe? Yeah. And that's what I thought. There weren't too many. But it turns out when you're a global company, there are people who are really interested in flight simulation. And there are almost, I don't know how many billion people on Earth now. So we managed to become known in the flight simulator community all across the world. So the company was founded in 2003 by my bosses, Magnus Axholt, whom you saw in the video, and Stephen O'Connell. And we're about 27 people now. Also, we're an international company. Our headquarters is in Stockholm, where I am. But we also have members in the team in Canada, Austria, Czechia, India, Ukraine, Australia, and 2 in the US. And we also have 2 offices in Stockholm, and many people are working remotely from their home. So we don't have anyone in Belgrade yet. Maybe someone of you will be interested, I hope. And how you buy this software then? Well, it is a subscription model, so you can pay for a month, or if you want to subscribe for a year, you can subscribe. And then we also sell data business to business to other companies in the flight simulation ecosystem. This was really interesting when I became part of Navigraf to see that how big flight simulation is. When we went to the Flight Simulation Expo in Houston, I think there were about 3,000 participants in this expo, so it was a fairly large conference. And there are like hundreds of companies all over the world working with add-ons for flight simulation products. For example, there are people doing aircraft. So some companies, they're only focused on producing as realistic 3-dimensional aircraft where the instruments work exactly as they do in a proper airplane. And those people who do that, for example, PMDG, they buy our data so that when you're looking into the cockpit of the airplane, you can see data coming from Navigraf in the cockpit of the airplane that you're looking at, that you're playing with, so to speak. And this way we have, in fact, managed to get our system also into the Xbox. So if you're using certain aircraft, you can actually use our maps when you're playing Flight Simulator on Xbox as well. So yeah, this is the team. Most of us are software developers, but we also have a team doing content, doing videos, tutorials on how to use the software and so forth. And marketing people, and then of course we need people to manage our websites and manage our payment systems and so forth. And what is interesting and what I think is a real key to our success is that actually we have many pilots in our team. So I think we have at least 4 real pilots who have a pilot license. We have Jason in Canada, who's flying Airbus regularly. We have Andreas, whom you saw in the movie, flying the flight simulator. He's a pilot, flying for Navigraf. And we have Emma, who's working in marketing. She was a pilot of private jets before. And we have our young software developer Malte, who's only 20 years old, but already has a pilot license for flying private aviation. And so this means that we have people who know exactly what it is to plan a flight and what is needed when you're planning a flight and what kind of data is needed for flight. So as you see, Magnus, he says sometimes, Navigraf, it's the company where the sun never rises. It's always night somewhere. So we're distributed all over the world. Yeah, so these are our founders. Stephen did research into augmented reality, as Mina showed. So he's an expert into using that, probably for the military at some point in time, but has also worked for Eurocontrol. And Magnus did his PhD thesis together with Stephen, I think, and then they started the company together. So what we do then is we have one of the main features is these airport charts. Have you heard of airport charts? Do you know what it is? Yes. Yeah? So we buy the same ones that they have, that the pilots use, for both for private aviation and for commercial aviation. And we can show them on the map, and we can then have what is called moving map functionality, that is showing where your plane in the simulator is on the map and on the airport chart. So I don't think anybody else actually has that in the same way. There are some other open source software, but it's not really complete, and it doesn't have the Jeppesen chart. And this is very much appreciated by real pilot, because they want to have the real thing as real as possible. So every month we are actually updating our data with a new AIRAC cycle. I don't know if you've heard about that, but the airplane data is updated. Different charts are changed. There's always something happening in the world with how you're flying into the airports, how the airports look, and what kind of radio beacons and ILS systems and whatever is installed, and how you're supposed to fly in and so forth. And the same thing goes for the procedures, how you're supposed to fly into an airport and how you're supposed to take off and how you're supposed to fly if you have a missed approach or something like that. And then when you're planning the flight, we also have route calculation, and you can also import the flight from various external sources using the route string, for example. And in order to plan your flight, you should also be able to see the weather. So lately we have been adding more and more weather functionality so that you can see what kind of weather there is out there when you're flying. And this is actually real weather. So when I was on vacation with the family this summer, I actually used our weather functionality to see if we were going to have rain or not. It's quite nice. So you can actually do your flight planning on the bus, on your mobile phone, or on your iPad, or on your computer. And then when you get home to the computer to do some proper flight simulation, you can then fly the flight that you have planned on your phone, for example. So this aviation data then can end up in the flight simulators. So there is functionality in Microsoft Flight Simulator, which is the most well-known flight simulator, but there's also Explain and Prepar 3D. So we can then change our data so that it can be imported and used into this flight simulation software. And then, as I said, also used by these third-party companies who are developing airplanes. So, for example, there are those who are developing the best 737 jet, or somebody doing it in an Airbus or a Vision jet or whatever. And then there's something that we have done lately, and that is that we have actually developed our own flight instrument. I don't know if anybody has heard of Garmin 1000. So we have actually developed our own Garmin 1000 instrument that if you install this one, you can have our maps on the Garmin 1000 sort of in any aircraft in the simulator which uses a Garmin 1000 avionics module. So that way we can sort of get our data and get our maps into the cockpit. And this is important because many people are doing flight simulation. They are actually flying with the virtual reality headset. You know, those kinds of things you put on your head, like an HTC or whatever different brands there are. And then, if you want to see the map when you have a headset, well, you have to see the map in the cockpit. So, by having our own instruments, our maps and our navigational data gets into the airplane that you see when you're using the virtual reality headsets. So this is a bit of a challenge, in fact, because the programmatic environment in Microsoft Flight Simulator is a bit constrained. So our third-party developers and our developers have to be really skilled in making performance software so that you will be able to use these fairly rich and interactive maps in the aircraft. And the way this is done is that there is an API for the navigational data and other data that you see on the flight simulator, but also Microsoft and Explain have APIs for getting the position of the airplane in the flight simulator so that we can access this one. And just as Flight Radar does, we have a software called Simlink, which is our sort of receiver of positional data and telemetry from the aircraft, for example. So we can get that, and then we can then, in our system, then position the airplane on our map. So we have to have the moving map functionality. And we can now also do that in the Xbox, in fact. So, but what happened a few years ago is also that Navigraf acquired another company called SimBrief, which is actually a one-man company. I don't know if you heard of SimBrief. Yeah, one flight simulation enthusiast there, I'm happy to see. SimBrief is probably the most professional flight planning software there is. And from what our pilots are telling me is that the flight planning that you have done in SimBrief is almost exactly the same as what he got as a Ryanair pilot. So when you're doing this flight planning, you get a package of documents outlining how your flight's going to be, from which waypoints and so forth, and lots of different data. And so he had a Derek Mayer from Canada. He had this as a hobby and has been developing this software for free. But he didn't like to work alone, so we found a deal where he could work together with us. And now we're integrating Derek's software with our software as much as possible. And then he's also integrating our Navigraf maps into the SimBrief planning tool. So this is interesting if you want to know what is the life of a pilot. How does aviation work? How does flight planning work? How does it actually work on an airport? for a pilot, because the way we do it is actually very, very, very close to real-world flight planning. And what SimBrief also does is that he does performance profiles, so he has data on the airplanes so that you can calculate fuel consumptions and things like that. And he can take into account weather, or at least use maps of weather for the flight planning, and validate that you have actually filed a proper route. And what he's also doing is that he has, through his users, collected other people's routes. So if you want to fly a common route between some airports, you can often find that route there, so you don't need to plan it yourself. Maybe there's a pilot who has filed, how do you fly from Stockholm to Belgrade? Well, then you can probably find that route and then use it in the flight simulation and then fly exactly the same way as a certain flight did or a certain pilot did. So when it comes to flight planning, we're also doing routing. I guess routing is something that you do here in the faculty, maybe? So how, using different airways, do you get from point A to point B? So there's a bit of route calculation there. And we also then have an interface for planning your flight, how you're supposed to fly into the airport, from which direction you're supposed to come, and so forth. And then you can, graphically plan the flight. So let me show you how this works. So let me see. So say that we want to fly here, for example, from Stockholm to Belgrade. So then I make a new flight here, and then I can find the Stockholm airport. And here you see these different standards for airports. SI is, I think, is it ICAO? And A... Huh? Ah, yeah, great. And ARN is the IATA designation, right? So we add Stockholm as an origin from our flight. And then we want to take off from a runway. And when it comes to runways, they are named. Does anybody know what this 01L means? Yeah?
It is the heading of the runway, in which direction it is pointed.
Yeah. In degrees, yeah.
It's divided by 10 and then rounded to the closest.
And the L?
The L is if there are multiple parallel runways that have the same direction, so you can tell them apart. One is named L and one is R.
Yeah.
There's one in the center being C.
Correct. Great. So actually here then, if we zoom in to Arlanda, and I want you to look especially at the railway and the power lines that you see here, because I have designed those. Very important. But if you zoom into the airport, you can see here that there are two runways. One is 07, this 07L. We have that one here, right? I have a difficulty to see it. Yeah, it's 071L. 01, I mean. And here you have 01 right. So then you're supposed to choose a runway here, and then we have actually some help here because we can see the weather. So we have the wind. So how are you supposed to take off? Yeah? Yeah, so you're supposed to take off against the wind. So here we have 11 knots headwind, I think, from 01L. So this one is all green. So this looks like a good airport, not airport, but runway to take off from. So we add this one to our route. Now, once we have selected the runway, we want to select a departure. And so here we have all the departure procedures from the 01L runway. And if we're going to Belgrade, which one do you think we should take? Yeah, well, I'll say we take this one. It seems to be heading mostly in our direction. Maybe Nosli. And these ones are actually named normally by some waypoint that you have underneath here, which is close to the Swedish city of Trosa. So let's select this one. And we can actually select different parts of it. But let's take it like that. Okay, so now we know how to take off. And this is normally something which is mandatory for the pilots to fly. I think the departure and the approach they have to follow. But what comes after this nowadays is actually in this area, I think, free flight. Have you heard of something called FRA? What does it actually mean? I've forgotten. It's something like free route airspace, right. So here the pilot is allowed to plan his flight not only according to the available lines that you see here. These are the airways that are available from the Trosa waypoint. So in free route airspace, he can fly however he wants, actually, I think, from the entry of the airspace to the exit, if I'm correct. But normally we auto-route according to the waypoints. But now let's select also Belgrade. Nikola Tesla. So yeah, now here we can first choose an arrival, the standard arrival routes, or what we call the star. So yeah, this one looks closest to where we're coming from, so I'll just choose this one. And I think the star is not mandatory anymore either if you're doing. I've been tracking my flights for fun when we are flying with the family, and I see that, oh, it's not going to the star. What's happening? It's like, no, they're going directly to the approach in order to save fuel, and often apparently the air traffic controllers just say continue to final approach, and then they can fly the shortest way, which is actually very, very important. And why is this important? Because the flight can then save a lot of fuel from flying the shortest path. So, but anyway, let's take a standard arrival here. This one, and add this to our route. But then, when landing in Belgrade, we need to choose the runway. And yeah, which one should we choose? What? 12 right, we choose 12 right, okay. And then we can choose the final approach. So this one looks good. We take the one that is using the ILS. There is also another approach using the RNAV, which is another navigation way of navigating into the airport. Now, what we can do here also is to view these charts that I was mentioning. So for this one, we might want to have extra information and see how are you actually going to fly into Belgrade, to this runway. And so here the chart tells you how you are supposed to fly in, where you're coming from, which waypoints and which altitude you're supposed to have in different distances from the airport. And you also have communication frequencies to the tower and so forth. And also this dashed line here, I think, is the missed approach. So that if you're coming into the runway and you're not able to land, there is a defined way that the airplane should take if you're missing the approach. So let's then add this to our flight. And here you can have actually this one also as an overlay, so we can put it on top of our map, and we can then, if the chart is geo-referenced, we can see exactly, if we push this button here, and if I had been flying on my computer, I would see a symbol here with my my airplane where it would be on the map. Now, this is very important if you're flying in a multiplayer environment. I don't know how many of you have heard of something called VATSIM. One? Yeah? It's one VATSIM in here. I think we're hopefully going to make you happier in the future, because we aim to do more integration with the VATSIM community so that you will be able to get data from the VATSIM network and see not real airplanes. Well, you might be able to do that as well, since my wife is working at Flight Radar. I'm hoping that we might get real airplanes into the simulator. We'll see. Any case, what we want to have is to have the simulated airplanes coming from VATSIM, so that you can see where your friends are, and you can see which airports are currently manned by virtual air traffic controllers. So there are actually people who want to be air traffic controllers and want to practice doing air traffic control in a multiplayer environment. So it's just like multiplayer gaming, where people are talking to each other, and they are very strict. The VATSIM community, they don't sort of like people flying just for fun anyway. They want to be real air traffic controllers, so that's actually why Navigraf is so popular in this community. It's because how are you supposed to follow the air traffic controller's instructions if you don't have a map of how you're supposed to fly? And we're actually one of the only ones who provide that. And actually the air traffic controllers that are in VATSIM, they are using our maps to route the aircraft to the airport. So when I was at the Flight Simulator Expo in Houston, I sat next to an air traffic controller whilst he was controlling airplanes coming into Puerto Rico airport. And when he was routing the airplanes, he was using our software to see which approach would be appropriate for the airplane that was coming into his airspace. So that's something we want to do more. So that is the chart. And here, a particular challenge which I'm working on often is to have these lines, which are our lines, correspond exactly to the lines on the chart, which is actually quite difficult sometimes, because the way this works with turn radius and speed and whatever, and different kinds of segments of procedures is actually a little bit complicated. So what's really funny was I actually got to use my maths skills, which are not as good as my wife from the mathematical gymnasium, of course. In fact, when I met my wife, she tested me. It's like, are you really good in mathematics, as you say? So I had to solve some kind of mathematical puzzles. Luckily, I managed. I don't know how, but but there's actually quite a lot of maths involved here, mostly geometry and trigonometry, and to sort of calculate angles and intersections between circles and lines and whatever. Quite fun, actually. And this is actually one reason why I find this job funny, because the normal kind of programming and software development that I have been doing previously is just rather boring, getting data into a database and then getting data out of a database. That's what's like 90% of all software developers do. We get data somewhere, we put it in a database, and then we take it out. But here, we also put data in the database and we take it out, but here it's graphical, so it's beautiful. It's lines, and the bugs are much more interesting. It's like if you make something wrong, you might end up with a sort of spiral or something else interesting. So much more fun, and much more mathematical, which is fun. So yeah, so I think we have actually planned our flight here, and now we might want to know what the weather is like. So we have recently added weather layers. So here we have weather radar. Oh, we see the weather is not, it's not too good here. We have a lot of rain here. And we have, let me see if there's any significant, oh, there's even significant weather here, the Sigmets, north of Belgrade here. I don't know what it is, but we can click on it and see. So, I'm sorry, does anybody, can anybody decrypt the Sigmet here? What's happening here north of Belgrade?
Thunderstorm northwest and geographical coordination 1, 2, 3, 5 row, or 4th row.
Okay, so there's a thunderstorm. Oh, okay, it says thunderstorm here as well, yeah. Yeah, that's a good hint. Oh, thank you. So, and I think these are probably coordinates of the figure that you're seeing here, right?
We expect a thunderstorm between, I can hear, please scroll down, or up, from 1447 Zulu to 1547 Zulu.
Okay. Yeah. So,
But not too low. I think that for us it not will be a problem.
yeah, because you have the
On
flight.
the flight level 360.
Yeah. So the flight level is, of course, really important here when it comes to the weather. So if we're looking at the radar here, I think we can also. Normally we have a control for some weather. Let me see. Here is the flight level control. So you can see what the weather is on different flight levels. And you also have turbulence, you have icing, cloud cover, and so forth. And now what is fairly new is that we can also have the telemetry, so that you would, when you're looking at the map, you can see how your plane is flying and how fast it's flying and so forth. So, but I think that's hopefully gives you an impression of the user interface that we have. And here you can see also the route string, which we can import from SimBrief, and you can get from Eurocontrol actually how you have planned the flight. And then we also, I should probably show you, did I do any auto routing? No, I didn't do any auto route here. Well, let's do that. We can calculate if we're not doing in if we're not in a free route airspace, we can route the aircraft according to the airways that you have. And in this case, the airplane will follow these airways, which are between in different waypoints and so forth. Yeah. Are there any more questions here? Yeah?
Yes, one question. Is there an option to validate the route directly to the Eurocontrol?
No, I think validation, it can be done, I think, in SimBrief, but I'm not exactly sure about how that is done. I don't think we validate with Eurocontrol. We don't have that integration. Flight Radar has more of that kind of integration, but we don't have it yet, so that's on the wish list, maybe.
I know that Eurocontrol also have the public access for user to validate any route on their NOP portal.
Aha, okay.
So this is my question. Is there possible to connect these two options?
Oh, that would be interesting. I have to look that up. Thank you. What you also can have here is user waypoints. Well, I cannot show you all the functionality. You have to figure it out for yourself. But now I'm going to do the second part of the presentation, and that is more, how does it work? Because you might be interested in maybe doing a similar kind of system, or if you want to come working at us, what kind of technology are we using to produce these maps? And this is actually sort of my area of expertise, the geographical information system that allows us to produce these maps. So as you might know, geographical information systems can deal with spatial data, and spatial data can be points. In this case, it's the gates when at an airport, or it can be lines, which in this case power lines, or it can be areas, polygons, which are outlining an airport area. And for altitude, we are in fact using radar data from, I don't know if we're actually using SRTM, but probably derived from that. There's open source data so that you will get the elevation, so that we are able to produce a sort of three-dimensional map and know where the mountains are and so forth. So we are processing all this data. And then we're also getting data in this shape from different sources. One is the raw ARINC data, which is used in I think the airplanes, some systems. There is a standard for how procedure data looks and how waypoint data looks and so forth, the ARINC 424 standard. So we can process that data and make it into geographical information. And then we're also buying data from Jeppesen for visual flight rules. And we're also buying data so that we can show you how the airport looks. So we have the Airport Management Database, I think it stands for. And we're getting the gates from Lufthansa. And then we're getting a lot of data, in fact, from OpenStreetMap. You can produce fairly nice maps just using open source data. And if you're interested in doing your own mapping, OpenStreetMap is a fantastic resource for producing your own maps. In fact, I have had use for it when it comes to moose hunting, for calculating the areas of different hunting teams. And then we get the weather from the weather. And the technical infrastructure of this is that we put everything in a database, as I said. We have to do that as well, get all the data into a database. So are you doing any programming in this course or in this program? When you're doing geographical information systems? No? No? It could be interesting. Because this database that we're using here is called PostGIS. And so this is a geographical database that is able to handle geographical database and answer questions like, are you inside an airport area? Does this line cross another line, for example? How far is this point from the airport? You can ask the database these kinds of spatial questions. So this is very important when we are combining these different data sources, so that we are combining OpenStreetMap data with AMDB data and the Jeppesen VFR data, and then we have to choose which one is best and which one is supposed to be used if they're overlapping, for example. So this is the merge and magic, which is done by my colleague in Ukraine, in Lviv. And then we have a particular challenge, and that is we are producing maps for the entire world. So this data set of the entire world is fairly large, right? The world is large. So we cannot download the entire world onto the computer. That would take too much time. It's like 35 gigabytes of data. So what mapping software is doing then is it's doing something called tiling. So you're only like downloading the data that is in the viewport. So you're only downloading the data that you're actually looking at. This is called tiling, and we do this with something called vector tiles, which means that we are downloading to the client only the raw data, the lines, the points, and the areas. We're not doing the style. This we can then put on an Amazon cloud for download in a specific format, so that it's easy to download just the data that you need in a very fast way. So we're using the cloud, AWS in this case, various technology database, and then we're programming the client in Node.js, web development, modern web development technology. And we're also using something called React Native, which allows us to have almost the same code base for mobile, for iPad, for web, and also we have a desktop application. But me, myself, I'm more of a back-end programmer, and I'm a Pythonist, so I use mostly Python to automate this process of map creation. So one of the challenges when doing mapping is that the raw data that you have, this is the vector data, doesn't look very nice. This is Heathrow Airport. It's not a very usable map. So this is what it would look like on the client if you didn't do it with styling. So with styling, you can actually tell the browser how the data should look. So, for example, if we have taxiways, these are the taxiway layers. We divide the data into different layers. So these are the taxiways of the Heathrow Airport. And then we can style each layer so that it will be shown differently in the user interface. So we can change the color here, for example. And we can, for example, look at My Pride, the power lines. Let's see if we have any power lines here. Yeah, here we have the power lines. We can style them in different ways. So this is all done in the browser, so we don't have to calculate that on our servers, but it's calculated in the browser. So that's the styling, which is a big part of geographical information systems, which you need in order to do nice maps, so that you can produce our map, which looks like this. That's how the map is produced. And if you want to, if you want to get into to learn about geographical information systems, the way I did it was I was introduced to this tool called QGIS, which is an open source tool, which is a very advanced tool for working with geographical information systems and working with these geospatial databases such as PostGIS. And this is actually quite an easy way to get into this line of work of working with geographical information systems. And it doesn't cost anything. And it's a tool which is, we don't find any reason to pay like huge amounts of money to buy ArcGIS or some other commercial software. We're quite happy with using the open source tools for this. So yeah, I was just going to end with what kind of challenges we have and what we aim to sort of do more of in the future, and that is use the aerospace information in a more three-dimensional way. We already have our globe view so that you can zoom out and see the terrain in 3D. But we can do more with 3D when it comes to airplane routes and showing how you have been flying and so forth. We can do more advanced routing, especially with free route airspace. And then there's also, of course, also the challenge of keeping the cost down in doing efficient computing. And we can do more integration with flight simulators, for example. There is much more of this data that we have that we want to get into the flight simulator somehow. And then helicopters is a specific area which we are researching in, like what kind of mapping and what kind of information do you need for flight planning for helicopters. So yeah, we are hiring people. So we have a position opening for a full stack developer, and this is actually possible to do from Belgrade as well. Yeah, that's about it.